Section 6.2 deals with the law of cosines. So although you're going to have the advantage of doing your homework knowing that you should probably be using the law of cosines, you're not going to know that on the test. So make sure that you identify how to use, or basically identify when to use the law of cosines over the law of sines. We said the other day that when you use the law of sines that you should have an angle on the side opposite that angle. Well, when you have the law of cosines, basically you're not going to have that. You're either going to have all three sides or you're going to have two sides and the angle in between them. So for the first one, got four of them for you today. First one, we're going to solve the triangle where you're given all three sides. And again, you should know to use the law of cosines for that. Second one, you'll be given two sides and the angle right in between them. And that again should be a clue to tell you to use the law of cosines. Third one, they're going to ask us to use Heron's area formula. I'll mention it when we get here, but again, be careful. In the test, I probably wouldn't say use this formula. You would have to know to use that formula based on the fact that they gave you three side lengths. And then the last one is finding the bearings given a story problem. And basically, it's finding the angle in the triangle. All right, so the first one, solving the triangle where they give me three side lengths. So again, like I told you before, I always like drawing a picture just so I have something to look at. Label your sides and angles however you want, as long as angle A is across from side A and so on. And doesn't matter how accurate your picture is, just something to look at. I'm going to use that equation that we kind of manipulated to find the angles since I have all three sides. So I'm going to find angle A to start with. So I'm going to say the cosine of angle A is equal to side A squared first, so 2 squared, minus side B squared minus C squared, and the order of those two doesn't matter. So minus 6 squared minus 7 squared. It's just when you look at the numerator, you should see that the only one that's positive is actually side A, because I'm looking for angle A. If this was angle B, then that should be side B. Divided by negative 2, that's just part of the equation, and then BC. Whatever these two numbers are, the ones that are negative, they should also be in the denominator, and it doesn't matter which order they're in. Alright, and like I mentioned in class, what I would like you to do is tell me what this fraction is. So go ahead and use your calculator so you can tell me what the numerator's fraction is and the denominator's fraction is. The reason I like seeing that is it's easy to see if you've made an error looking at those numbers. So I know it's 4 minus 36 minus 49, or that's going to give me negative 81 in the numerator, divided by 6 times 7 times 2, and of course it's negative 84 in the denominator. So I can see that it's going to be negative 81, negative 84. When I'm grading it, I can quickly look at those numbers to see, oh, you got a mistake there. Easy to figure out. I want to now take the cosine inverse of. You can either figure out what that is as a decimal or just type that in. I don't need to worry about the negatives because they're both negative, so it become positive. So the cosine inverse of 81/84 is going to give me, or tell me, that angle A is approximately 15.358, or I'm just going to say 15.4 degrees. Alright, so I've got angle A. Now I need to find angle B or C next. Again, doesn't matter which one you try to find next. I'm going to go ahead and try to find angle B next. So I would say the cosine of angle B is equal to, now when you set this up, this was this is angle A. The positive one here was side A. Since this is angle B, I should have 6 squared as the positive squared term in the numerator, minus the other two, and it doesn't matter the order, so minus 2 squared minus 7 squared, divided by negative 2, that's just part of the equation, and then whichever two are negative up here, these two, those numbers just drop down here. That's how I remembered it. Then again, use your calculator to tell me what the numerator number is and the denominator number is separately. So 6 squared minus 2 squared, or 4, minus 7 squared, or 49, gave me negative 17, divided by, I know the denominator is going to be negative, 4 times 7, I guess I don't really need a calculator for that, negative 28. Again, I like seeing those two numbers in terms of grading it. And then you can either convert that to a decimal or just type in cosine inverse of 17 divided by 28, and it tells me that angle B is going to be approximately, we'll go to one decimal place again, 52.6 degrees. And then if I've done it twice, I should be able to do it a third time, no problem. I realistically do not have to go through these steps again to find angle C. I now have two angles of the triangle, so I should easily be able to find the third angle by just subtracting. So what would make sense, the quickest thing to do would be 180 minus 15.4 minus 52.6 And that's going to give you approximately, let's go ahead and type that in, minus 15.4 minus 52.6. And it gives us approximately 112 degrees. So let's go ahead and say that angle C is approximately 112.0 degrees. And now I've got all of my answers. Again, if you want to do the work that you did here for angle C, if you've got time, I suggest doing it. Then you can add these three together, and if they don't add to 180, you know you've got a mistake. Because you're rounding this, if by some chance you add these together and you end up with 179.9, it's probably because of the rounding. You're probably fine. All right, there's the first one. Second one, I noticed that I'm given one angle and then two side lengths. So again, I'm going to draw a picture just so I have something to look at. And like I always say, my pictures always look like they're equilateral. It's more just for me to look at. It's not to be overly accurate necessarily. 4, 9. All right. And I didn't mention it up here, but when you looked at that triangle, notice that I have this side, but I don't have this angle, and that's what I look for the law of sines. I don't have that, so I know I can't use the law of sines. Don't have it, don't have it. When I look here, have that side length, don't have this angle, have that side length, don't have the angle, have the angle, but don't have the side length. I don't have the information required for the law of sines. That tells me that means I must be using the law of cosines. And now I'm going to use the original law of cosines equation. I'm going to be looking for side A, that's what I'm going to end up finding, and it's going to be A squared is equal to B squared plus C squared, and again, realistically, it doesn't matter which one's which, so I can say it's 4 squared plus 9 squared. They're added together, so if you rearrange those, it's not going to make a difference. Minus 2BC, again, they're multiplied together, so the 4 and the 9, it doesn't really matter which one you write down first or second, times the cosine of angle A. And then please show your work like I asked you in class. Go ahead and add those together, tell me what that is, figure out what that is, and tell me what it is. And so I've got 16 plus 81, and looks like that's going to give me 97, so A squared is equal to 97. Go ahead and type this in. Now notice you're subtracting it. So if you get a negative number when you type all this in, you would have to switch this to addition. That's the most common mistake. Other common mistake, this is the law of cosines. Make sure that you actually type in the cosine of 135. So if I type in cosine 135, I always do that first, times 9 times 4 times 2, I did not say negative 2, I get a negative 50.9. This is already negative, so subtracting a negative, I should say this is now plus 50.9117, let's say. Anytime I'm rounding an angle, I always go to one decimal place. It's just my rule of thumb. If you want to go more, you're fine. Anytime I'm doing a side length, I tend to go more. Again, if you said it was 50.9, I would be okay with that. Now, of course, once I've seen those two numbers, you can add them together, knowing that that, again, is the most common mistake. That's why I like to see it. Quick add those together. And I can say A squared is equal to 147.9117. Go ahead and take the square root of both sides. And I will get that A is approximately, and now that this is the final answer, I'll go to two decimal places. It's 12.16. They didn't say whether it was in feet, inches, miles, whatever, so we'll just leave it without units on it. And now it did say solve the triangle. And so the temptation is now that I know that this is 12.16 and I have an angle on the side across from it, let's go use the law of sines. Like we mentioned in class, it's a bad idea because when you do that, the information that you're going to be using is side-side angle, and we learned in section 6.1 when you're doing the law of sines, when you have side-side angle, there's two possible triangles, and so you may end up doing all your work and actually be incorrect. My general rule is if you start solving a triangle using the law of sines, finish using the law of sines. You start using the law of cosines, you probably should finish using the law of cosines. So what I'm going to do now that I have all three sides is I'm basically going to do what I did up here. So I obviously have angle A, don't need to worry about that one. Let's go ahead and find angle C. So the cosine of angle C is equal to, remember to start with side C first, it's 9 squared minus the other two sides squared, doesn't matter the order, so minus 14 squared minus 12.16 squared divided by negative 2 times 4 times 12.16. And again, tell me what those decimals end up being. So I've got 9 squared, which I know is 81, minus 16, minus 12.16 squared. Go Go ahead and hit enter, and it gave me negative 82.8656. Alright, divided by, I definitely know that's a negative number. It's 12.16 times 4 times 2, and that's going to give me negative 97.28. And again, your choice if you want to figure that out to one decimal and then type it in, or go ahead and type in cosine inverse 82.8656 divided by 97.28. And again, I can disregard the negatives because they're both negative. If one of them is negative, make sure you put the negative on one of them. Hit enter, and it looks like I've got an angle C, which is approximately 31.6 degrees. If I look back at my triangle, I have all three sides. I've got two angles, and now I can run through this process again to find angle B, or the quickest thing would be angle B is going to equal 180 minus the 135 I was given, minus the 31.6 that I just found. And so I type all that in my calculator, 180 minus 135 minus 31.6, and I end up with 13.4 degrees. And now I have solved the triangle. So remember, big picture when doing this problem, because it's not overly difficult, is if you start using law of cosines, finish using it. If you start with the law of sines, finish using it. It's just a good rule of thumb. Not that you have to do it that way, just recommended. Now, like I mentioned before we actually got to this problem, or when I was running through just describing them, on the quiz or the test, I probably would not say use Heron's area formula. You would need to know that when I ask you to find the area and I gave you three side lengths, that you need to use this formula. So make sure you're aware of that. Alright, well, I know Heron's area formula has this S in it, so I have to find S first, and I find that by adding all three side lengths together and then dividing by 2. So I'll take 12 plus 15 plus 9, divide it by 2, and I get a nice number. It's 18. And so now the area, using Heron's area formula, is going to equal the square root of S times S minus A, so 18 minus 12, S minus B, or 18 minus 15, and S minus C, or 18 minus 9. And now I just need to type that all in. So again, show your work. Quickly tell us that that's 6, that looks like it's 3, and this looks like it's 9. I'll go ahead and type all that in so I know what number that is. So 18, let's see here, slide this over, 18 times 6 times 3 times 9, and I end up with 2,916. And then go ahead and find the square root of that, since that's what we are looking for, and I'm going to end up with 54. So the area of my triangle is 54 square units. Again, since they didn't give us any units, we'll just leave the units off, which for the math they tend to not give us units, but it's square units. Alright, on to the last one. It gives you a story, and then it basically gives you the picture, so you almost wouldn't necessarily need to read this, although I would suggest reading it in case there's more information in there. It says on a map, Orlando is 178 millimeters due south of Niagara Falls. Denver is 273 millimeters away from Orlando, and Denver is 235 millimeters away from Niagara Falls. The two things they're asking is find the bearing of Denver from Orlando and find the bearing of Denver from Niagara Falls. So if you remember when we're talking about bearings, you always look north-south first and then east-west. So if I looked at letter A and I try to figure out by the picture what they're asking me for, find the bearing of Denver from Orlando. Here's Orlando. Remember, we're starting there because it says from Orlando. It looks like I'm looking north and then I'm going to the west. I need to know what that angle is. Well, I've got all three sides of this triangle, so I can basically do what I've done for some of the other problems, just find that angle. And then if you look at letter B, find the bearing from Niagara Falls. So starting here, I would look south and then I would look to the west. It looks like I want that angle. So really just finding the area of a triangle, but they give you the information in a story problem. So looking at letter A to start with, since I want this particular angle, I want to say that I'm going to, let's just call it angle A. Cosine of A is equal to, I need 235 squared first, minus the other two, so 178 squared minus 273 squared, divided by negative 2 times 178 and 273. And so, calculator time, 235 squared minus 178 squared minus 273 squared, and that should equal negative 50,988 divided by 2 times 178 times 273, and that's negative 97,188. And again, I'm looking for an angle, so I'm going to type in the cosine inverse of 50,988 divided by 97,188. Hit enter, and it tells me that it's 58 point, let's round that to 4 degrees. So, for letter A, the bearing of Denver from Orlando, Orlando is here, I have to look north, and then I'm going to look that angle to the west. So this would be 58.4 degrees west. There's the answer for part A. Part B, same idea. We're going to start from Niagara Falls, go to Denver, so I want this angle. So I'll call this angle B. Cosine of B is equal to, make sure you start with side B first, 273 squared minus 178 squared minus 235 squared. Order these two again doesn't matter. Divided by negative 2 times 178, 235. And again, order those two doesn't matter. So let's type in our calculator again, 273 squared minus 178 squared minus 235 squared, and that gives me negative 12,380 divided by negative 2 times 178 times 235, which is negative 83,660. And then we'll type in cosine inverse of 12,380 divided by 83,660, and looks like this angle is 81.5 degrees. So again, I'm looking south and then to the west, so I would say it's south 81.5 degrees west. And there would be my bearing to Denver from Niagara Falls. Hopefully that helps you out with your homework. If not, you're again always free to come in and ask for help.